About how to change from radians to degrees using a graphing calculator. Super simple. Basically, you just go to this mode command right here. Oh, turn on mode, and then you get all these different things. There's a lot of different modes you can change from, but today I just want to talk about degrees and radians. So right now you can see that radians is highlighted over here. So if you want to just switch to degrees, you go to the right and press enter, and whatever's highlighted in black, that is what mode your calculator is in. So let's just kind of give it a test. So I'm going to quit. You can just clear and get out of here. So right now I'm in degrees. And so you may have seen in geometry or physics a triangle like so. That is a 30, 60, 90 triangle. And if you remember 30, 60, 90 triangle, this is a special right triangle where if the hypotenuse is 1, then the short leg is half of the 1, so it's just half. And then to get the long leg, you just multiply your short leg by root 3. So this ends up becoming root 3 over 2. All right, so let's say you were asked, what is the sine of 30 degrees? Now, according to SOHCAHTOA, we know the sine is so, or opposite over adjacent. So the opposite over the adjacent, which is the 1/2 divided by the 1. So 1/2 divided by 1, which is clearly just 1/2, or 0.5. So if I plug it in the calculator and I do the sine of 30 degrees, I should get 1/2, which makes perfect sense. Now, let's say I changed the mode and went to radians and did the same thing. I can do second enter to redo it, and that would give me a totally different answer because now we're in not degrees, but we're in radians. 30 radians is much larger than 30 degrees. And so let's kind of see how this would work in terms of radians. So if you kind of look back if you look to my right, this is the radians section. Here's a unit circle. If you had a circle that had a radius of 1, so these are all radiuses, let's say they were 1, and you remember that in radians we have, over here at the right, we have a coordinate pair of 1, 0, and up here we got 0, 1. Now let's talk about the actual radians. And so we know up here, this 90 degrees is pi over 2. And we remember that because the whole circle is 2 pi. So if I divide that by 4, I know it's pi over 2 at the top. So what does that mean this 30 degrees is? Well, we know 30 degrees, 60 degrees, 90 degrees, so it has to be a third of this pi over 2. So we know this angle has to be pi over 6. And so if once again, I know that the coordinate pair for this guy is, we know this is 1/2 and this is root 3 over 2, the same as the degree section. So I know this has a root 3 over 2 and a 1/2. Now, if I were asked, what is the sine of pi over 6? You can think of this as two different ways. We can just do same thing, opposite over adjacent, and get 1/2 over 1, but we already knew that. We can also think of this using the unit circle. Once we know our pi over 6, we look at our coordinate pair over here, and we know sine has to do with the y value, and the x value has to do with cosine. So I know the sine of pi over 6 is going to equal 1/2, which makes sense. So let's test it using our radians. What is the sine of, where is our pi? Over here, sine of pi divided by 6, and you get 0.5. So totally makes sense. One last thing I want to mention. If you are in physics or calculus, both AP classes or not, whenever you're in degrees, physics, always put your calculator in degrees. If you are in calculus, always put your calculator in radians. If you're taking both classes, well, you have to kind of switch your calculator's mode constantly, but don't forget, be a big bummer if you chose the wrong mode for problems.